Okay, so just for a quick reference here, guys, the purpose of balancing a reaction is to make sure that we obey the law of conservation of mass. Okay, we can't create matter, we can't destroy matter, and we can't change it into something else. So we have to make sure that we balance a chemical reaction so that we have the same amount of everything on both sides. Okay, so a reaction would look like this, where I start out with two hydrogen molecules and one oxygen molecule, and when I'm done, I have 2 molecules of water, but I have the same number, 4 atoms of hydrogen and 2 atoms of oxygen. Okay, it's all conserved and balanced. All right, so that's the purpose behind that. Okay, and when we're balancing, okay, we write out the reaction, obviously, okay, and usually, if it's not a combustion reaction, we balance the atom or ion present in the greatest number, right? And we use coefficients, that's the big numbers that go in front of a compound, not the little numbers that are in it, okay, to get equal numbers of atoms on both sides, and then we repeat that step for all the other ones, okay, and then we double check when we're done to make sure that anything we've done hasn't thrown something off, because it does occasionally happen. Right, where we're going through a reaction, we balance something and it throws something off that we've already balanced, and then we have to look at it again. All right, so we've done that reaction already in class a couple of times. Now, for predicting the products of a reaction, okay, I just gave you guys a flow chart there that kind of will walk you through it, right? But I want to walk through it with these 4. Oh, did I not give you 3? Oh, there you go. All right, so the first step in predicting the products of a reaction is to identify the type of reaction. What type of reaction is going on in one? Synthesis. It's 2 elements. All right, now, if it's 2 elements reacting, okay, they're going to form what? A single compound. All right, one of these is a metal, the other's a non-metal, so they're going to form what kind of compound? An ionic compound. All right, so which thing should I write first in this compound? The calcium, right? Because we always write the metal first, right? So calcium is going to come first, and oxygen is going to come second. Okay, this is a -2, this is a +2, so that's already dropped and swapped correctly. I know I have now my product predicted, right? What do I have to do next? I have to balance it, right? There's 2 oxygens on the reactant side. There's only 1 oxygen on the product side. So I need to put a 2 here and then go over and put a 2 there, right? Now it's all balanced. So I've predicted the products and balanced. What we can't forget are the little things, okay? The little things are like, how do I write ionic compounds, okay? I know that what I often do, okay, on like a quiz or something is I give you a synthesis reaction like that, except I would write it like this. Okay, you would be shocked how many people will write the product as this. Is that how I write an ionic compound made up of a metal and a non-metal? Nope. But because I wrote it that way in the reactants, people write it that way in the products without thinking about the little things. Okay, the little things being we don't write ionic compounds with the non-metal first. Okay. The reaction might be written that way, but we have to write the products, okay, the proper way on that one. Okay, question number 2. What kind of reaction is that? It's decomposition. It only has 1 reactant. That is the only reaction type we've gone over with only 1 reactant. In a decomposition reaction, what is going to happen to this compound? It's going to split, right? So it's going to split, and I'm going to have magnesium as an element and sulfur as an element. What do I need to check for? All right. Right, we're going to have to put an 8 next to it. It's one of our molecular elements, okay? It comes as an 8 when it is by itself. That's something I always have to check for. If I get an element as a product or I have an element as a reactant, I need to make sure it's not special, or if it is special, to put the right number on it. Okay, magnesium's not special. Sorry, magnesium, it's not special. Okay, but we have to now figure out our balancing. Now we got the products right. Okay, start with the biggest number. Sulfur's an 8. So I put an 8 over here. That gives me 8 magnesiums. Now I got 8 magnesiums. Reaction's balanced. Okay, it's always the same steps. identify the reaction type, okay, look at what that reaction entails, write the products, drop and swap them if they're ionic, check for special elements, and you're done. Okay, then balance, sorry, then balance. Check for special elements, then balance. All right, try number 3. I'll give you a minute or two on that one. All right, number 3, what kind of reaction is that? It's a combustion reaction. Okay, combustion reactions always have the same products. What are they? CO2 and water, right? Okay, we have special balancing rules for combustion reactions, okay? And that is that we balance alphabetically and the rule of 2, but we don't need the rule of 2 because 3 is an odd number. So I put a 3 here to balance my carbons, balancing in alphabetical order, okay? 8 hydrogens, so a 4 here will balance my hydrogens. I have 4 oxygens plus 6 oxygens gives me 10 oxygens, all right? So is this really a whole lot different than what we were doing before? Not really, okay? Except that we were given the whole reaction before and now we have to figure out what the products are, okay? It really isn't that much extra work to figure out what the products would be. Okay, try number 4 there, okay? Don't worry about number 5 for now, just try number 4, okay? And maybe we'll get through that one before the bell goes. Let's quickly look at this one. So we got a double replacement reaction, okay? And in a double replacement reaction, the metals switch partners. So that means hydrogen will end up with whom? With hydroxide. So in other words, water, okay? And that means sodium ends up with chloride. So we have water and salt, okay? And that's what the products of an acid-base reaction always are. That's hydrochloric acid and sodium hydroxide, 2 very strong acids and bases, okay? You always get salt, some kind of a salt, and water, okay, depending on what the base was. All right, so that is what we'll be working on next week, okay, predicting the products, balancing, all that kind of stuff, okay? If you get a chance, have a look over your, get some of your lab report done this weekend, okay, or look at your toxin project, that kind of stuff. All right, start planning your time. It's going to get very busy very fast here.